Hi, hello guys, welcome back to my channel. It's really nice to have you guys here, and it's always fun, for me doing this video. If you're a returning subscriber, thank you for watching my video. And if you are new here, thank you for also clicking on my video. And within some few minutes, I hope I'm able to convince you to kind of stay and watch my video and subscribe to my channel. So in today's video, we are going to be learning about linear regression. Okay, so this video, if this is the first video that you are watching, just to let you know that this is the fourth video in this series. So we are doing a machine learning series, for young people and for old people that are new to the field of AI and machine learning. So if you're someone like that, I will really encourage you to stick around. And if you are new to machine learning, I will kind of encourage you to go back to the first video and start watching from there. But if you just want to know just how linear regression work, yeah, maybe you can watch this video only. But so let's get right into it. So just like a recap from what we did in the last video, in the last class, which is the third class, so we look into data, like how is data used in machine learning, right? And how to get data set, how to use data set to teach our machine, right? So we did a lot of stuff, and we were able to do some exercise, to kind of explore our data, to kind of see what is in our data. Because don't forget, machine learning is all about data. You have to give the AM data, to kind of learn. And I've given these examples like many times, as a student, as a child, when you go to school, what you get in your brain is data, and you are able to use the data to learn. Okay, so the same way machine learning needs data. And just imagine that if your teacher teach you nonsense, right? So like your teacher gave you wrong data, you are going to learn nonsense. Okay, so if you give your AI nonsense data, nonsense is gonna also give you nonsense. So data is very, very important. So I hope that you guys were able to learn a lot of stuff from that. Okay, so what we are learning today, we are learning linear regression. Okay, so again, kids that are very young, will be like 9, 10, or that you might just be like, oh, linear regression is the very big word. Okay, so don't worry, I will break it down for you that you will understand, right? So you don't have to memorize the definition of linear regression, but it's just for you to know what is linear regression, like have good examples in your brain. Okay, so in today's class, we're going to be looking at what is linear regression. We're going to be looking at examples of linear regression. Okay, example of linear regression data. Okay, then we're going to design our own linear regression model. Okay, so linear regression is an AI model. So technically we are designing our own AI model today, and I think you guys should be excited about it. Okay, so then we are going to teach the regression model, how to know stuff. Then we are going to do some hands-on activity to test our model. I think my picture is kind of getting in the way in here, but you guys should see what this is. It's just test the model with values. Okay, so yeah, so that's what we're going to be doing today, and we're going to write a lot of code, not too much. I mean, like, not too hard. Okay, so but it's going to be fun. Okay, so but before we go into the code, I just want to explain to you guys what linear regression is. So before we go into linear regression, so I would like to break this down so that you guys it won't be complex for you. So if we have linear regression, the first thing what is linear first? Okay, when someone say linear, what do they mean? Okay, so what does linear mean? So linear, okay, refers to relationship between two things. Okay, so when someone say, like, use the word linear, it is like linear is always used when two things are involved. Okay, so they can say, oh, the car is linear to the road, or like the boy is walking linear to the road. So there are two things involved when they want to say something is linear. Okay, so for example, I give the example of the age and the height of a child, right? So so the age and the height of a child, they are linear, right? And then I'll also explain what that means. Okay, so linear means the relationship between the two things form a straight line. Okay, so that means the relationship between the age and the height of a baby forms a straight line. So that means as the age of a baby or a child increases, the height of the baby also increase. Do you guys agree? So that means it is a straight line. Okay, as the height is increasing, as the age is increasing, age is increasing, height is increasing, age is increasing, height is increasing. Okay, so then this I gave example of what straight, like linear means. So like this one is linear, straight line in any direction. Okay, this one is linear, this is linear. Then you can see this one is not linear, and this one is not linear, and this one is not linear. Where, like, someone can argue that as a child gets very old, maybe like after 25, that the height will not increase. But let's just assume that the relationship between the age and height, it's linear continuously. Okay, so that is linear. So we understand linear now. Linear always involves two things, right? And it's the relationship between two things, and the relationship like form a straight line. Okay, so now what is regression? Okay, so regression is actually a statistical tool, but I removed that so that like some kids won't get confused. But let's so like regression is used in statistics. Okay, so regression is a tool used to know the relationship between two or more things. For example, how does age of a child affect the height? Okay, so we know that the age and the height are linear, right? But now we want to know, how does the age affect the height? Meaning that when the baby is 1 year old, how tall will the baby be? When the baby is 2 years old, how tall will the baby be? And 3 and 4, right? So regression will kind of tell us that. Okay, so now if a baby is born today, now we can use regression to say, oh, in 10 years the baby will be this tall, right? That's kind of, so like that's what regression is trying to predict, and that's what our AI is about, like to teach our AI to make prediction about two things that are linear, right? So I just gave example of age and height. It could be anything, right? So again, regression is used to predict one thing, right, a variable, from another thing, a variable. Can we know, this one is not supposed to be here. Can we know the height of a child from the age, right? That's what I say, like from the age of the child, can we know the height? Okay, so that's what, so linear is we have two things that their relationship is straight line. Okay, regression is the one that will say, oh, the two things that have relationship, I can actually predict one if you give me one, right? If you give me the so like a child is born right now, in 10 years I can predict how tall the child will be. That is regression. Regression will do that. So we want to design a regression model and train the model to be able to make that kind of prediction. Okay, so the height and age is just example. Okay, so the code that we're going to write is actually so different from height and age. Okay, so but I think it's still going to be something that we all learn from. Okay, so now that we know linear, we know regression, so now let's put everything together, two of that together. I hope my okay, yeah, I'm good. So now linear regression is a tool used for knowing the relationship between things that are linear. Okay, for example, age and height of a child. Okay, so that means as the age increases, the height increases. We can use linear regression to predict height for a particular age. Okay, so now you see linear, you see regression, you see linear regression. Okay, so just look at this graph. Okay, so again, if you are very young, you don't understand it, it's fine. Okay, just listen. Okay, so let's say this is the age of the child, or so let's say like the child is 0 here, then maybe like this child is maybe like 2 feet, right? Then the child is 1, then the height of the child increases, the child is 3. So you see, as the age increases, the height increases, right? So then it forms this straight line. Okay, so this is what the linear regression is trying to do. So like the linear regression is trying to fit this line so that it can predict height from age. Okay, so so therefore for people that are older that knows some math, okay, so I will write an equation, right? So if you remember, so again, if you're a kid, if you don't understand it, it's fine. Okay, so if you've done math to this level, if you remember in math, right, so we have equation of a line. So and we know that y is equal to m x plus c. This is high school math, so if you don't know it, it's fine. Okay, so this is the equation of this line. Okay, so for people that are older, right, that are watching this video, so what the linear regression is trying to find is this and this. Okay, so the linear regression is going to give us the slope, like this is the slope, right, and this is the intercept, right? So the linear regression is going to solve for this and this. So if we are able to get this and this, so for any age, so we just multiply it with our gradient and add it to our intersect, then we'll get the y. Okay, so for young people, please, yeah, if you don't understand that, please, it's totally fine. When you get to high school, you understand what I'm trying to say, right? So that is what the linear regression is trying to solve internally. Okay, so but for the young people, let's just go on the high level. You know, we have linear regression, we have two things, and we want to predict one from the other. Okay, so I think this is all the slides that I have for you guys, so we'll just go straight into the code. I hope that you understand what linear is and what regression is, and the two together. Okay, yeah, so please, if you have any question and something is not clear to you, you can always leave a comment in the chat down there, and I'll respond to it. So now let's go and code. Okay, so the first thing that we need to do, we need to go into our Google Colab. Okay, so again, I explained to you guys last time, you know, two ways. So if you've like shut down your laptop or your Google Colab is not open, right, two ways to go to Google Colab. So the first thing, you can go to the email that you use, that you are using for your Google Colab. So this is the email that I'm using, right, my iOS synapses, right? So in that, make sure that is the same email. In that email, then you click on all of these dots, then you go to your Google Drive. Okay, because our code is being saved to Google Drive, so then you can just open the the last one that we did, which is lesson 2, or you can even open lesson 1, you know, any one that you want to open. So this is lesson 2. Then you cannot just come here and say new notebook, okay? Or you could just go to colab.google.research.com, right, and it will open for you. But you see, this is a different account, right? So what I will do is just cancel it, then switch it to my account. But I won't do that because I have it open right here, okay? So make sure that you know, like, those 2 ways not to open your code. Then I think this is small so I don't get into trouble, people asking me that they can't see the code. That's good, okay? Thank God I remember. So now this is lesson 2. So now we want to create a new file. So we go to file, so we go to the new notebook, okay? So it's loading up. So we're gonna call this lesson, lesson 3. I mean, like, this is video 4, but this is the third code that we are writing, okay? Good. So then I can just close this because I don't need it anymore, okay? So now let's start writing code, okay? So but before we start writing code, so remember I told you that we need data, okay? So the data that we're going to use, and I told you guys that we're going to be using Cargo a lot, you know, to get our data. So the data is going to be student score data set, okay? So this data is just trying to say that, oh yeah, so like you remember that I told you about linear. So like linear means there is a relationship between 2 things. So this data set is trying to say, is there any relationship between the study hours of a student and the score that the student will have in the exam, okay? So that's what this data, so like this data has list of all study hours and the score that students would have, you know, if they study this amount of time. So the goal of this is to train an AI using linear regression to say, if I study for 4 hours, what score will I get? If I study for 10 hours, what score will I get in my exam? Okay, so that's the goal of this, okay? So we need this data. So this data, I have downloaded it, you know, and I'm going to leave a link in the description that you can just click on it and it will download it directly for you. Okay guys, so the data that we are going to be using is in here, but I already downloaded the data for you, so you can see the data in the link below. So just click the link below and the data will be downloaded for you, okay? So that is all you need. So like the data should be there for you to use, okay? So you don't have to download it yourself, but I'm just showing you where I downloaded the data from, okay? So so now, assuming that we have our data, so let's now come to our Google Colab in here, okay? So the first thing that we need to do is to import our data, because we need our data, right? So just click on this folder, wait for it to connect, and expand this. Please don't forget to expand this, then click on this 3 dots at the front of the sample data. So click on it, so then you say upload file, then you should see my own file is down here. I don't know why. So after you download the file, you should see it in your download folder. So it's going to be studentscores.csv. so you just click on open. So you just do this. So now our data is here, okay? Our data is here for us to use. So if you want to just close it, it's fine, but so I will close it so that I will have some space to write my code. Okay, so let me do that. Let me check if my my video is not blocking anything. Okay, so again, I've written the code before. I'll just try to just copy and paste because I don't want this video to be long, but I will make sure that I explain each of the lines not to you guys. Okay, so remember, the first thing that we need to do is to import some of the libraries that have been, so like the libraries are code that have been written for us already that we can just reuse. Okay, so again, so this is what is called numpy. Okay, so it's used for some calculations that I don't have to explain to you guys right now. Then this panda is used for data processing. This one is used for plotting. We're going to plot some graphs. Then this one too is used for data. Then this is going to be our model, right? So this is going to be our linear regression model that we are going to be using. So like the model has been created for us, that is, the AI is already there for us. So all we have to do is just to train the AI. Okay, so just imagine this as the brain of a baby that has not learned anything. Okay, so now our goal is now to teach the baby how to do things. Okay, I hope that makes sense. Then please make sure that you don't make any mistake writing this. Okay, so once you are finished, so we don't need to use GPU for this. By the way, I think CPU is enough. So once you are done with that, then you just click on this. Everything is good. Then we create a new code, okay, in there. So now we want to load our data. Okay, so let me copy the code over again because I want to save time. I'm not lazy, I just want to save time. So you can put this comment in here. Then you can see this file path is column, then period, sample data. So like this is saying that our data is inside sample data and it's going to be student score. Okay, please don't if you make mistakes, this is going to give you error, and if you get error, please just come back and check it again. Okay, so this is a file path. Then we need to load the data, so like to read the data, and since the data is CSV, so that there is a function in these pandas that can read CSV. So then we read the CSV inside here. Okay, so now this one is just so like this is the data right now. So this data.add is just to show us some information about the data. Excuse me. So now when I run this, see what we so you see. So this one, so we loaded the file. Then this one just shows like the first 5 data points. So you can see, so we have two things that has linear relationship, right? Remember the definition of linear. So then I gave example of the baby age and height. So now is study hours and exam score. So this is saying that if you study for this amount of time, what is going to be your score in your exam. Okay, that's what this is trying to say. And then this is just like a sample data, it's not real data. Okay, it's just to teach you guys how linear regression works. So you can see these are the first few data points in there. Okay, so hopefully you don't have errors. Then we go to the next one. So let me go and look for the code for the next one. So this next one again is just to get information about the data. All right, so it's also a very simple code. So get information about data set. So study data, which is the data that we got from our csv.info. If you do this will just show you some information about the data point. So let's run it. So this one shows us that we have 2 columns, hours and score. So the hour is the study hour and score is the exam score, and we have 25 data points. Ideally, when we want to train our model, we should have thousands of data points, but just because we are using linear regression for testing, so our next model will be I think I call it multivariate regression. Okay, that one we are going to use real data, and we are going to develop a model that we either predict if persons like someone we have cancer or have some diseases and all of that, and that is very useful. Okay, today's one is just for testing. Okay, so next video we're going to like the model that we're going to be creating will be tough. Okay, so that's for this one. Then let's do the next one. So the next one also is just again to explore the data, to see, because it's always good to know what is inside your data. All right, so this one is just saying describe the data for me, what is in the data. All right, and it's just, you know, like the hours we have 25. Then the mean of it, you know, if you don't know what mean is or how to calculate mean, it's fine. Okay, yeah, so the mean just mean the average, the average of the number of hours. Okay, then the average of the exam score is this, then standard deviation, you know, like all of this. If you don't understand, it's fine, but it's just something that I should expose you guys to, you know, for the young people. Then for the old people here, I mean, like not old people, like, you know, older, you should know all of this. Okay, so now let's just visualize. So we've not even started training the data. Okay, we are just trying to explore what is inside our data, because like I said, data is very important, so you need to know what is inside your data, you know, before you use it. So now let's do some plotting. Okay, so this is gonna be some code that's gonna, so we want to plot. So this plot is coming from here, right? Coming from matplotlib. Okay, so just say plot figure, just write this, you know, exactly. So what we are plotting here is our study data. So like we want to see how the hours and the score kind of relate to each other. Okay, so then just say plot.show. So you can see here, so this is what you should have. You can see like the one that I showed you before, the height, no sorry, the age and the height. So as age is increasing, height was increasing. So also the same thing, as number of hours that you study is increasing, your score will increase. So if you study for 9 hours, you have a probability of getting 100%. Again, this is just like a sample data point. Okay, so that is for this, no, just to visualize the data. Okay, so and I think we did some visualization last time, but it's just for histogram. This one is called scatter plot. Okay, I'll be introducing you guys to small, like some of the plots, you know, but if yeah, you don't have to cram it. Okay, so what's the next thing? Let's see. I think the next thing is to prepare our data for training. Okay, so let me copy the code over again. We'll start the training very soon. Okay, so data preparation. Okay, so remember, so we have the study hours and then we have the score. So we need to put the study hours in a specified variable and the exam score in a variable. Okay, so then our data, if you remember, our data is inside study data. Okay, then inside study data we have hours and score. Okay, so we want to separate the hours in a separate variable. We want to separate the score into this. Okay, so then we are also reshaping. So like this one is just to clean things up, so you don't have to really bother yourself about it, but just write it the way it is. So like this is just to reshape this so that we can do some calculations. Okay, so just write this the way it is and you shouldn't have any issues. Okay, make sure that you don't miss anything, miss any spelling, and I think this is big enough. Let me check. Yeah, that's big enough. Okay, so let's just run this. So everything good. So now I think the next thing is this, is to so I will explain this one too. So you remember in the last video that I said that our data, that we have to split our data into train and test, you know, right? So so that's what this is doing. Okay, and let me explain this, you know, in a simple term that you understand. Okay, so if you go to class and your teacher teaches you, you know, maybe multiplication table, maybe like 2 times 1 to 5 or something, right? So when your teacher want to give you exam, your teacher will give you exam, you know, on other multiplication table, right? Because your teacher want to know if you actually know it. So like your teacher will not give you the same example that they gave you, that he or she gave you in class in your exam, right? She will give you something different. So that is what this is doing. So we are going to train our AI with like a train data point, then we are going to test it with like test data point, right? Because if we train the AI with a data set and you want to test it with the same data set, you know, like that won't, like we won't know if the AI is actually good or not. Okay, so again, we need to always split our data to train and test. Okay, so you are using 75% for training and 25% for testing. Okay, so please just write this code the way it is, then when you run this, you should be good. So let's do the next one. So the next one now is actually training our model. So create linear regression model and train it. Okay, so our linear regression model is equal to this, right? So then remember I told you that this linear regression model is already given to us because we imported it from here. Okay, so but it's an empty AI. So this is what we use to train. So you say regression model dot fit. This fit means train. Okay, so fit, so train with our x train, so x is going to be our number of hours of study, then y is going to be our score. Okay, so please note that. Then we just do this, then we have this. So we've trained our model. Yeah, again, it's very small data set. Ideally it should take like 5 minutes to train, but because we have very small data set, so it trained very quickly. So now that we have trained our model, now we want to, so we train it on x train and y train. So now we will test it on x test and y test. Okay, so let's do that. Let's see how many, so what's the accuracy of our model. Okay, so let's do this. So I hope this is not difficult for you guys to put. So like this is just saying print, then you put this bracket, then you say f, then don't put space between f and quotes. So do that, just write it the way it is. Okay, but what this is trying to do is our regression model, we are trying to test it with our x test and y test and see what is going to be our accuracy. Are we going to be 100%? Are we going to be 50% or 60%? So let's test it out. So I will run this. So we can see our model is 86% accurate, right? I mean, that's still a good number, right? So that means our model is 86% right all the time. Okay, which is kind of like a good score. It is almost like 90%, you know. And remember that we don't have enough data, right? So that's, you know, that's one thing too. So we can see that. Okay, so so I'm gonna put another one code. So like this code again is for, if you don't understand it, is fine. It's for people that are older that really understand math. You know, if you remember in here, you know, I put this equation that we are looking for this and this, right? So, and that is what this is means, right? So our linear regression is able to give us the value of m and also the value of c. Okay, that's so like this is coefficient, which is slope, which is m, and the intercept, and that is what it's calculated here. Again, if you don't understand, fine, just write this code and you see the result in here. So now the next thing that I want us to do, which I think is going to be the last one, is now that we know that we have a model, right? So and the model is able to give us the like what score we will get in exam based on the study hours, you know, that we like the hour that we used to study. So now let's test it. Okay, so let's test it. So let's assume that you study for 5 hours, right? So then just write this code this way. So we put study hours equal to 5, then study hours we put it in here. Okay, so then we write this way. So when we print this way tell you if you study 5 hours, what exam score are you gonna have? Let's see. So if you study 5 hours, you are gonna have 51%. So that's actually interesting. So let's do, if you study for 8 hours, what are you gonna get? If you study for 8 hours, you're gonna get 80%, which is not bad. Okay, so I think so that is the end of this, you know. As you can see, so the point is that we have data, right, and we are able to load the data, and we are able to use linear regression to kind of train our AI, which is what is here. So you know, if you have any data points, you know, that have just two things that are linear to each other, so you can get the data from anywhere. Maybe like a data that says that says the age of a child and the amount of food they eat, something like that, right? So you can train a model for that, and then you can say, oh, for this particular age, this is the amount of food that the child will eat. Okay, something like that. Just think in that line. Okay, so and we are able to achieve 86% accuracy, and we are able to test it with even different values. Okay, so the homework that I want you guys to work on is, you know, this one right here. So copy and paste it so many times and change this value of study hours. You know, you can change it to 1, 2 or something. Then let's see what our AI will predict as the exam score, okay, for this based on the study hour. So just copy and paste the code. The only thing that you need to change is just this, right? So for example, if somebody studies for 1 hour, wow, the person will score 12%. that's not good. Okay, all right guys, thank you so much for watching my video. Hopefully you guys learn a lot of stuff. Again, this is the 4th video in this series, and this is our first AI model, which is linear regression, which is the most simplest form of AI model that I know. So in the next video we are going to be doing a multivariate regression. Again, please don't get scared because of the word. Okay, so it's going to be simple. I will explain it for us, and we're going to write some code too. Okay, so please guys, don't forget to like my video, subscribe, and then also share with your friend, you know, at school, you know, let them know that, oh yeah, I'm learning AI and I'm really enjoying it, if indeed you are really enjoying it. Okay, so then one thing that I want you to know also is, in here this G is actually green. Okay, so if you want different color, actually you can do this, you know, then you have red, you know, and I think you can do yellow too. Yeah, okay, so that you can just play with that. All right, so thank you so much, and I also have some other videos too if you guys want to watch. I think they are very good videos. So anyways, I will see you guys in the next video.